Okay, so we're going to look at the solving of tangent equations, and once again I'm going to start by covering the three methods of solving for a very basic example, which is this one. So once again we're solving between 0 and 2 pi, and the question is tan of x equal to 1 over square root of 3. Now the first method, which is probably the one that you use... What happened to the cursor? The cursor's gone. Wow, it's back now. Okay. What am I saying? Yes, so the first method is the one that you probably learned last year, and that's when you're looking at quadrants. So regardless of which methods, we need to start with the base angle, which in this case, what is this? Very quickly, no one, pi on 6. So 1 on root 3, yeah, anyway, so just learn your exact values. Okay. So step 2 is to look at all station to city, or whatever acronym you come up with. So this tan is positive, and we're looking at the first and the third quadrant. So the first quadrant angle is going to be pi on 6, and the third quadrant angle is 7 pi on 6. So that's the quadrant method. Second method is the unit circle. Now there is an issue with tan that I think it's never as neat as sine or cosine, because tangent, it's not something that you can actually represent using the coordinates of the point on the unit circle, because tangent is the ratio between sine and cos. So we'll still start with the base angle, which is pi on 6. So pi on 6 is somewhere here, because it's around 30 degree. Well, it's not around 30 degrees, it's exactly 30 degree. But it's actually very hard for me to show this ratio, because it's not this length on this length. Tan is a ratio between sine and cos. That's one way to think about. I think that is the way to think about tan. It is a definition of tan, just opposite of adjacent or rise of a run. So one way to sort of get around that, and I know this is not technically accurate, but it will work if this is not a unit circle and it's just a circle, is you can think of this as the actual value of sine and cos. And again, it will work if it's a circle and not a unit circle. So this is the same as saying if tangent of this angle is 1 on root 3, it's the same as saying it's the opposite. Here we go again. I actually can't remember why I changed color to red. Let's say you can assume that this is 1 and this is root 3. Okay, so you're looking at the ratio of 1 over root 3. There is one other way to get the same ratio, and that is when everything is negative. So if you have, oh, actually, there's a better way to do that. If you have that, oh, Jesus. Okay. I'm going to leave it that, because otherwise we'll be here all day. So negative 1 and negative root 3. So this is also going to give you the same tangent. And I think visually it makes a lot of sense. This is the same line. So it has the same tangent or gradient as the original line. So we're going to look at this angle now. I'm actually regretting changing the color to red just before. I should have done it now. So this angle is going to be the second angle that you can have, because this angle here, this line will create a line with the same gradient as the original. And if you use a ratio, it is opposite on adjacent, which is a third again. Sorry, not a third, 1 over root 3. So from here you should be able to tell there are two angles. And this one, because of symmetry, that's pi on 6. So the whole thing is also 7 pi on 6. So x is pi on 6 or 7 pi on 6. Okay, so that's method 2. Oh, method 3 is going to be fun. So method 3, if anyone remembers from my previous video on solving, method 3 is going to be on using graphs. So once again, the base is still pi on 6. This is not going to work out too well, mainly because tan graph looks really ugly. Sorry, tan. I actually don't like you at all. Ooh, because the shape is weird. What is that? Okay, I mean, it ends. Oh, that is terrible. Okay, so there's pile 2 here. This is not working out. Let me double check. I just delete. Why did I do that? Oh, I just accidentally. I'm drawing the whole thing again. Again, this is like a gag show. Do not use this method. Can I just like not show this method? I can't even draw a straight line anymore. Okay. You know what? It was bad and then it got worse. I actually don't have to draw anything on the other side. So, pop quiz. What is the value of this asymptote? Okay, I actually got. This is pi. Did I just? Oh God, this is pi. Oh jeez, this is so bad. I'm stopping. I'm not gonna do this method. I'm sorry. Just stick with the unit circle. I can't even draw the 10 graph out, but essentially it's gonna cut twice and just be happy. Or if you can draw it, you can do it yourself. Okay, that's it.